In this lesson, I'll be showing you how to solve radical equations. A value with the square root becomes a radical. This is a radical expression. Once we have an equal to it, becomes a radical equation. So let's take this question. I'll be dividing it into two parts. The first part, we're going to be dealing with radical equations in simple forms, and the other part we are going to take it a step higher. Let's say we have x plus 2x minus 8 equals to 0. This is actually very easy. You should be able to solve this. X plus 2x 3x equal to 8. X is equal to 8 divided by 3, and you have the value for x. But if we should add this here, we have a radical equation. Now how do we solve it? To solve this, we can just change root x, change it to an ordinary value, a value without a radical. So we can say root x should be equal to a. Since root x is a, we can now add a here. But what of the x? To get rid of the square root, we can just square both sides. So when we square both sides, it cancels out the square root. We would have x equal to a squared. So we have x equal to a squared. So we can substitute these values. So now we have a squared plus root x is a minus 8 equal to 0. Now we can solve the quadratic equations. Once we have our value for a, we just have to bring it back here. Solving this quadratic equation by factorization, or if you don't know how to solve quadratic equations, check the description below. There should be a link there. We can solve this by factorization because we have minus 8 and the coefficient of a square is 1. So we have 1 multiplied by minus 8, that is still minus 8. The factors of minus 8, which when multiplied would give us, or the factors of minus 8, which when added would give us plus 2, are minus 4, and minus 2, and positive 4. Minus 2 multiplied by positive 4 is minus 8, so they are factors of minus 8, and minus 2 added with 4 would give us 2. So we are right. Those are the two factors we need. So we have a, since plus 2 minus 2 would give us 2, we just have to put that down. Plus 4a minus 2a is still the same thing as this. Minus 8 equal to 0. Factorizing, let's put them into brackets first of all. So you don't just cover the brackets like this. This becomes a product. So we have subtraction sign between operation between them. So the subtraction, we factorize that out. We have 2a plus 8. Since we are factorizing the negative operation out, this changes to positive, equals to 0. Let's look for common factors. Here a is a common factor because we have a 2 times here and we have a once here. So a is a common factor between both of them. We have a plus 4. If you open this, a multiplied by a is a squared. A multiplied, a plus 4, yeah. A multiplied by a is a squared. A multiplied by 4 is 4a. So that's correct. Here, what is common? 2 is common. So we have 2 as the common factor here. Minus 2. We have a plus 4. Minus 2 multiplied by a would give us minus 2a. And minus 2 multiplied by plus 4 would give us minus 8. So that is correct. And looking at it, we have two common expressions here, a plus 4, a plus 4. So it also shows us that we're on the right path. When factorizing, you should not have something different. If you should have a plus 4, you should also have a plus 4 here. You shouldn't have a plus 4 here then a minus 4 here. It means something is wrong. Or maybe you have a plus 4 here, then you're having a minus 5 here. Something is wrong. If you don't understand, you can check the video in the description below to learn about solving quadratic equations. So we pick one, a plus 4, and we pick the other, that's a minus 2. This a and this minus 2. A minus 2 equals 0. Since the I equals 0, we can say a plus 4 is equal to 0, and a minus 2 equals to 0. So for each value, we have a equals to minus 4, minus 4. Here we have a equals to 2. Our work is not done yet. We are not done yet. Don't forget, we have to go back to where we had root x equal to a and x equal to a squared. We want to get the value of x. Now to get the value of x, we just substitute our values for a into the equation. X is equal to a squared. So when a is equal to minus 4, we have x equal to minus 4 squared. This is 16. And when a is equal to 2, we have x equal to 2 squared, and x is equal to 4. So these are the values for x. We can try that out into the we can substitute this for x into our equation to see how correct we are. If we should add 4 here, 4, change it to 4, we have 4 plus 2 root 4 minus 8 equal to 0. Root 4 is 2, so we have 4 plus 2 multiplied by 4, 4 plus 2 multiplied by 2 minus 8. So that is 4 plus 4 minus 8 equal to 0. We have 4 plus 8. We have 8 minus 8 equal to 0, which is correct. 8 minus 8 is equal to 0. If we substitute 16, we have 16 plus 2 root 16 minus 8 equal to 0. 16 plus 2 root 16 is 4. So we have 16 plus 8 minus 8 equal to 0. 16 plus 8 minus 8 is 16, which is not equal to 0. So it shows us that 16 is not the right value for x. 4 is the right value for x. But in the option, if you have 16 and 4 and you don't have 4 only, you should pick 16 and 4. But if you have 4 only, you should pick 4. Let's take the other part. So this is actually a bit different. Here we have radicals in both sides of the equation. In both sides of the equation, left hand side and the right hand side. Let's bring the radicals together. Bringing this here, we have minus with a equals to, closing them in the brackets. Let's square both sides. When we square both sides, it's possible for us to clear out the square roots. Let's see. We have root a plus 12 minus root a plus 12 minus root a. So watch closely how I'm going to do this. This would multiply this, this would multiply this, this would multiply this, and this would multiply this. So let's take the first one. Root a plus 12 multiplied by root a plus 12. Once you have the same radical multiplying itself, the answer would be one of the values. Root 5 multiplied by root 5, the answer is 5. We pick one of the values, 5. So root a plus 12 multiplied by root a plus 12 would be a plus 12. Now root a plus 12 multiplied by minus root a. So you have to be careful here. Both of them are, it's not just an ordinary. Okay, let me show that to you. If it was an ordinary expression where we have a plus 12 multiplied by a, this would be a plus 12. But now both are both are square root. Should I say both are square rooted? Okay, both are square rooted. So since both are square rooted, we just have to add the square roots on top of it. Hope you get what I'm trying to show you. So we have plus minus a plus 12. I think it's rough here. Let's take it to the other side. So the first one, root a plus 12 multiplied by root a plus 12. We just pick one of the values because they are the same radical multiplying itself. So we have root a plus 12 multiplied by root a, and I showed you that it's just going to be adding the radical, then simplifying normally. So we have a plus 12. So let's check out the downward part. This multiplying this, also the same thing. We have a plus 12, and this root a multiplied by root a, the same radical multiplying itself. We just pick the value, which is a. So let us simplify this. Equal to the square of 2 squared is 4. So when we simplify this, we have a plus 12 plus this. A plus a is 2a. This plus this is 2 this. Since they are the same value, so we just add them together. We have 2a plus 12, then plus a equal to 4. So now we have a plus 12 plus this plus a equal to 4. We have a. When we add them together, we have 2a plus 12 plus 2 root a plus 12 equals to 4. So let us leave this at the left hand side and move every other thing without radical to the right hand side. So we have 2a plus 12 equals to 4 minus 2a minus 12 So we have 2a plus 12 equal to 4 minus 12 minus 8 minus 2a. We can get rid of this 2 here when we divide both sides by 2. But before we do that, let's factor out 2 here. We have 2 common here. We have minus 4 minus a. So now we can just divide both sides by 2. This 2 cancels out this, and it cancels out this. So we have root of a, then a plus 12 equal to minus 4 minus a. So you should know what to do now, since we just have a single radical. We can just square both sides to get rid of the radical, which makes our work easier. So when we square both sides, the square cancels out the square root, and we have a plus 12, and you expand this the way I showed you. Let me show you again. Minus 4 minus a minus 4 minus a. This multiplies this. Minus 4 multiplied by minus 4 is 16. This multiplies this. Minus 4 multiplied by minus a is plus 4a. This multiplies this. Minus a multiplied by minus 4 is plus 4a. Minus a multiplied by minus a is a squared. So we have 16 plus 8a plus a squared. So we can bring that here. We have 16 plus 8a plus a squared. So take a look at this. We can simplify this also. So we have, or we can just expand this. So we have a squared plus 12a equal to 16 plus 8a plus a squared. We have positive a squared here. We have positive a squared also in the left hand side. So both sides we have positive a squared. Since they have the same values, they're actually going to get out. Because if we actually take like terms and we bring this to the left hand side, it becomes negative a squared. It would actually move out of the way. So it's actually the same thing, since they are the same value with the same positive sign. So we can just get it out of the way at this time. So we have 12a equal to 16 plus 8a. 12a equal to 16 plus 8a. Taking like terms, that is bringing this here. We have 12a minus 8a equal to 16. Now we have 4a equal to 16. To get a, we divide both sides by 4. We have a equal to 16 over 4. We have a equal to 4. So you can just substitute the value of a into the question again and see if it's going to give you if it's correct. And yet it's actually correct. You can try that out yourself. I hope you learned something from this video. Don't forget to subscribe. Don't forget to give me a like. I'll see you in another video.